Hi everyone, welcome back to our channel. Today we are going to do the MATLAB simulation of compensation theorem. So when you see the circuit diagram, we need to develop this simulation diagram. So before, let's try to see what is the problem in this compensation theorem. So we have an electrical network like this, and the current which flows in this branch is 1.1 ampere. Okay, now the resistance is changed from 3 ohms to 1 ohm. So this 1 ohm resistor is added in this branch, and we need to find out what is the change in current. Original current is 1.1. Whenever an resistance is changed from 3 ohms to 1 ohm, we have to inject a compensating voltage that will give us the change in current. To find this change in current, we have a theorem which is called as compensation theorem or compensating theorem. So this is the electrical network before compensation. This is the electrical network after compensation by adding that extra resistance. If this resistor is added, what is the magnitude of change in current? We need to find out. So the theoretical calculations of this circuit is already there in our lecture. We can view from there, and we are having this compensating voltage is 1.11 volt. Okay, now let's try to see the basics of this analysis. So when you coming to this compensation theorem, so the compensating voltage Vc is equal to, we have the formula, the compensation voltage. So compensation voltage Vc is equal to the current in the branch multiplied with the change of resistance. This change of resistance we are going to call it as delta R. So here you can see here the compensating voltage Vc is equal to, so you can see the original current is how much? 1.11. Okay, so the original current in the branch is 1.11, and the resistance has been changed from 3 ohms to 1 ohm. Okay, so here you can see here the this branch is having a current, resistance of 3 ohm, and it has been changed to 1 ohm. 1 ohm is extra added. How much is added in the network is into 1. So this 1 ohm is added. Therefore, V equal to I into R. This is 1.11 volt is the compensating voltage that should be injected in the branch where the resistance is changed. So the compensating voltage of 1.11 is injected in the branch where the resistance is changed from 3 ohm to 1 ohm. Then automatically the change in current we can find out using compensation theorem. So this is all about the compensation theorem. This theorem is used to find the change in current or the voltage in any branch when the impedance is changed as delta Z. So the change in impedance is how much? 1, which is nothing but 1 ohm is added. So now let's try to do this MATLAB simulation. So before trying to do this MATLAB simulation, first open the MATLAB window and click on the Simulink. As soon as you click on the Simulink, click the blank model, and you'll be getting a blank Simulink model. You just slide it down and keep it in the right hand side, and the circuit what we have to design, let us try to keep in the left hand side. Okay, so this very simple. Here you can see here the simplicity of designing. Okay, so here we require one voltage source and three resistors, one ammeter, that's all. Okay, so one ammeter is sufficient to handle all these things. Okay, so now let us try to come to the, at the top you have an library browser. Click on the library browser. In this library browser, just scroll it down. Here you will be having Simscape. In Simscapes, come to specialized power system. There you have an fundamental blocks. From the fundamental blocks, drag the power GUI. We require an voltage source. Click on the voltage source and drag the voltage source. We require the resistors. Come to the next button, which is nothing but elements. Drag the series RLC branch, and if we require measurement of current, use this ammeter. So now let us try to construct the simulation diagram before compensation, the original circuit. Okay, so you can see here this voltage source is of 10 volts. Okay, the magnitude of this source is 10. Just enter the amplitude as 10, click on apply and okay. Okay, and this is a resistor. Double click on this resistor and label the branch type as only R. Click on apply as well as okay, and connect the positive to the resistor and write down this resistor value is 4 ohms. Okay, so the value of this resistor is 4, and click on the apply and OK button. Okay, and I want one more branch. Copy this branch and paste here, and just use a Control R button, which is nothing but rotate button. Okay, and you have to calculate the current in this branch, and I require one more branch also. Copy this branch here, paste here. So the value of this resistor is 4 ohm. Okay, so here this is 4 ohms and this is a 6 ohms. Double click on it and enter this value as 6 and click on apply and OK. Then here you are going to get 6 ohm ohms, and let's try to connect it. Okay, so connect from positive to, so connect this positive to the branch and connect the ammeter. So why I'm connecting an ammeter is this is the branch where I require the current, so connect it to this. So from the negative to connect to this resistive branch, and from here to here you connect it. Okay, and the value of this resistor is nothing but 3 ohms. Just keep it as 3 ohm, and here also you can enter it as 3 ohms. Okay, so now this is the original circuit before compensating. Now to run it we should have an power GUI and just see the output. So coming to the library, and you have to see the output. Outputs will be available in sinks. So drag the display and keep it here, and here you can see here, just run it. So then you are going to get the current what I already discussed before compensation is 1.1 volts. Now let's try to design the compensating circuit. Okay, so then our resistance is changed. So this is the DC source. Just copy the DC source and paste it here, and the original resistance is 4 ohm, and paste the 4 ohm here, and this resistor is not changed. Keep it as 6 ohm, and this is original 3 ohm resistor. Keep the original 3 ohm, and the resistor is added, I mean changed, as delta Z, where you are going to get this resistor as 1 ohm. Okay, the incremented resistance value is 1 ohm, therefore here you are going to get a 1 ohm resistor. Okay, so now when you do it, we are going to have an compensating voltage that also will be in opposite direction. You can see the diagram if you have any confusion. Okay, so I had already completed the simulation for this. Here you can see here this compensating voltage we need to inject. Okay, so take the same source, control C, control V, and label this voltage source as compensating voltage. So the theoretical calculations are already there. So let's try to give as per the circuit diagram. Okay, connect the positive to 4 ohm resistor and output of this resistor to single ohm, and try to make it as a single closed path. Now from the positive of the resistor, this is old resistor 3 ohm, and now we are going to add this 1 ohm resistor. So connect the 1 ohm resistor, and now we are going to add the compensating voltage, and from the negative you try to close. Okay, so as soon as you close it, you are going to get the compensating voltage. Compensating voltage, already I told, the current is 1.11. Current is at I into R is how much? 1.11 into 1. So then the compensating voltage you are going to get it as 1.11 volt. So, and this voltage source has to be deactivated. So just you make it as a short circuit. Okay, so the process of finding this is the original source has to be deactivated. Therefore deactivating a voltage source is indirectly making it like an short circuit. Okay, so original voltage value is how much? 10 volts. We have to deactivate it. 10 volts is converted as 0. The compensating voltage is added in the branch where the resistance is changed from 3 ohms to 1 ohm, and you have to find the current here. So in order to find the current, remove this branch and copy the same ammeter and paste it here, and connect the positive to positive and negative to negative, and just to use one display block here, and if the current connection is successful, it will show in black color, otherwise it will show in red color, and just run it. You can see the thing, it is showing it as 1.5. Okay, so let's try to check. The resistance value is 4 ohm and 6 ohm, and this is nothing but a 3 ohm resistor and 1 ohm resistor. Okay, so now the compensating current we need to find out. Okay, let us verify our original circuit. So the compensating voltage here we are going to add, which is nothing but 1.1 volt. So add this as 1.11 volt. This is the compensating voltage. Just click on apply and OK button. Just run it again. So here you can see here the source of 0. 0.17 amperes is the change in current developed when the resistance is changed from 3 ohms to 1 ohm. So the change in resistance can be easily calculated using an compensation theorem. This is called compensating voltage added in the branch where the resistance is changed and the increased current, which is nothing but, so when the current is flowing here in the clockwise direction, which is 0 point minus 0.17, whenever it flows in clockwise, I mean anti-clockwise direction, this is positive. So I will show that also. So control C, just copy that current source. Just you can show the current. Just remove this link. Just copy this current source and paste it here, and just rotate it. And now the source is from this side, so therefore I am connecting it to positive and connecting this to negative, and I am placing an ammeter here and connect this output to here. Okay, so just run it, you will get in opposite direction. You can see the current flowing from, since this is the source, the current is 0.17 is the change in current developed due to change in resistor. This is called the concept of compensation theorem, and this is the background of running an compensation theorem. Hope you are able to understand. So you can get the same from what I had already done it. Okay, so you can verify here also. The compensation theorem, let's try to verify. So this is the circuit what I had already developed. Okay, so here also you can see here, when you run it, the current is 0.1734 amperes. So hope you understood the compensation theorem very clearly. So let's try to meet in another video. Okay, so if you feel the way I solved the problem is very good and simple, please give a like to the video and share this with your friends those who are studying this subject. And if you have any doubts in solving this compensation theorem, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name kvthulasi at the rate evcrush. Thank you for watching. We'll meet in another video. Yours Ram.